And greetings, I'm Dr. Max Gomez at the 5th International Vatican Conference. And today I am with Jerry Shelton, who is the chairman, president, and CEO of Cryoport, and he's with us. Welcome, Jerry.
Thank you.
So, Jerry, as you know, when we go to these different kinds of conferences, scientific, medical conferences, and trade conferences, as it were, they're often very focused on specific issues, points that we talk about. What is different, do you think, about a Vatican conference, this kind of a conference, that makes it more valuable?
Well, I think it's the interdisciplinary approach to the conference, and and trying to fulfill that mission of improving the quality of life on a global basis. And you could say that it's embodied in the church's mission of the church speaking to the various cultures around the world. But you bring through these various insights. I mean, we really don't understand a lot about our very being. And so you bring in these various aspects of breakthrough thinking from experts around the world, and that's enriching.
Jerry, one of the things that I don't think very many people appreciate is when a drug company, for example, makes a medication, they make a drug, they're able to ship it, and it's kind of straightforward. When we talk about cells, those are living organisms that you just can't stick in a box, put in the back of a truck, and move along. Tell me about the whole issue of temperature-controlled supply chain. That's a big deal right now for everything from vaccines to cell therapies.
It's a very big deal. And one of the misconceptions is the thing that you mentioned. People think of shipping of just taking a box from point A to point B, like a FedEx or UPS or a DHL. But shipping cellular therapies is quite complex, and it requires temperature control. It requires condition control, because the biggest enemy of cells is temperature variation or humidity. But there are a number of other things too, like jars. Now, most people don't think about shock, but shock actually can create problems when you're shipping cells. We are technology centric. We meet all kinds of testing and qualifications. We validate everything that we do. We're sophisticated in terms of our packaging and our near-time, real-time monitoring, and in terms of the way we do the logistics of getting those cells from one place to another. Quite complex.
You mentioned validation there. I imagine that one of the things, because when you get a container of cells that reaches its final destination, that user may or may not know whether the cells are viable, how many are viable, and so forth. So you have to have some sort of documentation, I imagine, as to the fact that it was kept at a certain temperature within a certain range for the entire shipping?
Yes, Max. We run a very detailed audit chain, and without that audit chain, the therapy is not accepted. Because what we're trying to do, what we're doing is we're delivering efficacy. So every detail in biology is attended to and backed up with data. So that audit chain is examined the very first thing after arrival and before thawing.
Exactly. So how does it work? I imagine some of the vaccines are frozen in dry ice, but real living cells, that's a different. How do you maintain that kind of temperature control?
Well, our specialty is cell and gene therapy, and so in cellular therapy, there's a control rate freeze. And the normal guideline is a degree per second or degree per minute, but it varies according to the protocol. And so a control rate freeze takes place, because what you don't want is you don't want to break the cell membrane. You don't want to break the cell wall. So you're forcing out water and trying to prevent crystalline structure from being formed inside the cell. There's still some H2O left in the cell, and that looks glassy under a microscope, so people refer to that euphemistically as a glass point. And then once that's frozen, it needs to stay in that condition until it arrives to its destination. And then it either goes into storage or it's applied to, or the inoculation, it's prepared for inoculation to the patient. And at that time, it goes through a control rate thawing, because crystalline structure forms in the thawing process as well.
Interesting. So not simple, obviously. So it sounds like there's a lot of collaboration and partnerships that are important in this entire supply chain. Tell me a little bit about that. What kind of collaborations and partnerships have you been able to form to make all of this happen?
Well, we have a world of partnerships and collaboration. This business is filled with co-opetition and partnerships and collaboration. And so I'll give you two examples. One is Lonza and another is Novartis. And in both of those cases, for Lonza and Novartis, what we're doing is optimizing the supply chain to allow them to carry out their manufacture and delivery of therapies with efficacy. And that's the way we work. But those are two good examples.
So what's next, if you will, because this is a rapidly growing field, it sounds like. Where do you go from here?
Well, actually, it's all about growth. I mean, growth is what's next for us. This industry is just getting off the ground, and it's forecast to grow at 30 to 40% per year for the next decade. And we're the leaders in the field. We support 528 clinical trials and 6 commercial therapies. We help set the standards for handling cellular and gene therapies. So it's all about growth for us. And so the supply chain is complicated. There are a number of different steps to go in there. And with our partners, we're going to be working toward answering every gap in that supply chain from the point of extraction of blood from the patient all the way through the process to the inoculation on the other end when the therapy comes back, whether it's either autologous or allogeneic. I heard Dr. Jung talking about both of those a few minutes ago. About 30% of our trials today are allogeneic, and the other 70, of course, are autologous.
So I imagine then, as you were saying, there's a lot of education that happens on kind of beginning, middle, and end of this entire supply chain, so that everyone understands what are the critical steps and what has to be done so that nothing happens to affect the viability of the cells.
It's a very dynamic industry, and that education continues. And what we have to do is be in what I call the athletic stance, ready to adapt and support the industry as it continues to develop, because we are getting more and more finite in our work, dealing with the various organelles within the cell as well as the cell in total. And so that's exacting work, and we will support it all the way along.
Jerry Shelton, Chairman, President, and CEO of Cryoport, thank you very much. It's a critical part of what we're doing here for cell therapies, and thank you for your work.